Hello viewers, I am Ruhismita.
And I am Madhav.
Through this video, we are going to teach how to solve an LPP problem in MS Excel using Solver. We have taken a very simple problem of HR. Generally, HR problems comprise of many constraints. However, for ease of learning, we have taken a problem with 3 variables and 5 constraints. The problem definition is as follows. Organo India currently has 50 farmers farming organic products for the company. In order to efficiently and successfully carry out the various new projects in hand, it requires more number of farmers to produce so as to meet the increasing demands for organic products. Due to cost constraints, it is not in a position to hire all skilled farmers. Hence, the decision is to hire some of skilled, some semi-skilled, and some unskilled farmers. The total cultivated organic vegetables by a farmer in terms of its value in rupees are such that a skilled farmer contributes vegetables worth rupees 1000 per day. Similarly, a semi-skilled farmer contributes rupees 700 and an unskilled farmer contributes rupees 400. The organization has decided to hire not more than 8 skilled farmers, 5 semi-skilled farmers and 10 unskilled farmers. Also, the total production by skilled and semi-skilled farmers should not be more than rupees 12,000, and the total production by unskilled farmers should not cross rupees 3,200 due to lack of cold storage. So, our objective is to find out the optimum number of skilled, semi-skilled and unskilled farmers to be hired so as to maximize the total production. The problem formulation is as below. Skilled farmers is denoted by x1, semi-skilled by x2 and unskilled by x3. The objective function is 1000 into x1 plus 700 into x2 plus 400 into x3, which is the total production per day for the new hired farmers. Now we have to maximize the objective function pertaining to some constraints. The constraints are as follows. X1 should be less than equal to 8, X2 less than equal to 5 and X3 less than equal to 10. The total production constraints are 1000 into X1, 700 into X2 and which is less than equal to 12,000 and 400 X3 less than equal to 3,200. The non-negativity constraints are X1, X2 and X3 should be greater than equal to 0. Now moving to our MS Excel sheet. So this is MS Excel 2007 version. Please make sure that you have installed Solver. Now this portion is not necessary for solving in the solver. However, I have written this for your and my reference. This is the objective function and these are the constraints. These 5 are the main constraints and this is the non-negativity constraint which I have to split into 3. Now I'm going to write down the name of the constraints. Since I have 8 constraints in all, including the non-negativity constraint, I'm going to copy it and paste it 7 more times. I will change the number. What I have done here is name the constraints as constraint 1, 2, 3 and so on. The next parameter that I have to take is the number of farmers, which I'm going to write in this cell. And then the total production per farmer per day. Next, I'm going to write the categories of farmers, that is skilled, semi-skilled and unskilled. Now I have to write the values of production 1000, 700 and 400. Now these 3 cells represent x1, x2 and x3 respectively. I'm not going to write x1, x2 and x3 but leave it blank because the solver will solve the problem and send the values in these 3 cells. In this cell, I'm going to write the objective function. I'm not going to write it as such, but in terms of the cell references. That is, firstly it is 1000 into x1. I'm going to write this cell equals to this cell 1000 into this cell that represents x1. Next is 700 into x2, so plus 700, which is this cell, multiplied by this cell. Next is plus 400 into x3, so plus 400 is this cell and x3 is this cell. Press enter. So this is my objective function. Next, I will write the LHS side of all the constraints. So for constraint 1, my LHS side is x1. Hence, equal to my x1 is represented by this cell. Press enter. Similarly, equals to my x2. x2 is represented by this cell. Enter. x3 is represented by this cell. Press enter. Now next is 1000 into x1 plus 700 into x2. Hence, this cell multiplied by this cell plus this cell multiplied by this cell and enter. Next is 400 into x3 equals to 400 multiplied by this cell. Now next is x1, x2 and x3. Hence, equals to x1, press enter, equals to x2, press enter, equals to x3, press enter. After having written all the LHS sides, I will write the RHS sides of all the constraints. And I'm going to write them accordingly. For constraint 1, it is 8. I'm going to write the values as such, as they are absolute numbers. And for this, it is 0, 0 and 0. So what I have done basically is named the constraints as 1, 2, 3 and so on. Then I have written number of farmers in production. For production, I have written the values. For number of farmers, I have left it blank for the solver to solve and give us our answers. And these are the categories of farmers. For constraints, I have written the LHS side in terms of the cell references and not the values as such. And for the RHS side, I have written the values. Next, I will click on the cell which represents my objective function. That is this. This is my objective function cell. After clicking on this, I'm going to click on solver. So my target cell is the objective function cell. Hence, I'm going to select that cell. Because this problem is a maximization problem, I have chosen max. If it is a minimization problem, please select min. Next is the changing cells. So my changing cells will be the cells which will represent x1, x2 and x3. Now for the constraints, I'm going to add the constraints one by one. So first constraint is constraint 1, which is this cell less than equal to this cell. After adding one constraint, select add. Constraint 2, this cell less than equal to this cell. Make sure that you have the right symbol. Select add after adding each constraint. This cell less than equal to this cell. Select add. This cell less than equal to this cell. Select add. This cell less than equal to this cell. Now my non-negativity constraints, so the symbol will change. Hence this cell greater than equal to this cell, greater than equal to this cell, finally this cell greater than equal to this cell. After having written all the constraints, I will click OK and check if I have all my constraints. So next, I'm going to click on options and see if assume linear model has been checked. Select OK and then select solve. So this is my required solution. X1 is 8, X2 is 5 and X3 is 8. I will check if they are under the given constraints. 8 is equal to 8, 5 is equal to 5 and 8 is less than 10, which are all within the constraints. 11,500 is less than 12,000. 3,200 is equal to 3,200, which are again within the constraints. I hope you can now solve an LPP problem in MS Excel. Thank you, viewers.